All right, hello everyone. Fozzie's here and ready to help with topic 5. I hope you guys are ready to go over topic 5. All right, so what page should they turn to? What page? Go ahead and turn to page 98. He's right here. Go ahead and turn to page 98 in your practice book. And Foz is going to help us learn about topic 5. Right, Fozzie? All right, so I like these type of questions. I feel like they're a little easier than the previous sections, and they make more sense on how to make these graphs. The tough thing is going to be learning how to put things in vertex form. What you see here, g of x equals x minus 4 squared minus 5 is vertex form. One of the reasons it's called vertex form is because you can easily tell what the vertex is by looking at this. It's going to be the opposite of what x is being subtracted by. So see how it's being subtracted by 4 or added. It's going to be positive 4 for your x, and then negative 5. The negative 5 will stay the same for your vertex. So our vertex is 4, negative 5. Hopefully you see how I found that, and when you graph it out, you'll see that makes sense. And so vertex form can be really helpful. All right, so let's start with some x's. So if x was 2 and we plugged in 2 minus 4 is negative 2, negative 2 squared is positive 4, 4 minus 5 is negative 1. All right, let's plug in 3. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 minus 4 is negative 4. Let's plug in 5. We don't need to plug in 4 because we already know when it's 4, we get negative 5, which is our vertex. So if we plug in 5, 5 minus 4 is 1. 1 squared is 1, minus 5, negative 4 again. Plug in 6. 6 minus 4 is 2. 2 squared is 4. 4 minus 5. We get negative 1 again. So if we plotted those points, 2, negative 1, 3, negative 4, and then 4, negative 5, 5, negative 4, and 6, negative 1, we get something that looks like this. So hopefully you see how I solved that. Making a quick table can be really helpful and make it easy to graph a quadratic function. Luckily, when you're doing your FSA or your EOC, you'll mostly need to identify stuff with a graph. But practicing this will help a lot and help with understanding quadratic graphs. So let's move on. So now we have x plus 1 squared plus 4. So hopefully you can guess what the vertex is. So since this is plus 1, the vertex is minus 1. So minus 1 plus 1, and then we're left with 4. So negative 1 and 4. All right, so we're going to plug in some x's. You'll notice I mostly go with x's that are kind of around the vertex. So in this case, we'll start with negative 3. So negative 3 plus 1, we get negative 2. Negative 2 squared, we get 4. 4 plus 4, we get 8. Then if we plug in negative 2, negative 2 plus 1, we get negative 1. Negative 1 squared, we get 1. 1 plus 4, we get 5. We already know what negative 1 and 4 is. That's our vertex. So then let's plug in 0. So 0 plus 1, we get 1. 1 squared is 1. 1 plus 4 is 5. Okay, now let's plug in 1. 1 plus 1 is 2. 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. So we have a rough graph already. So let's go ahead and plug those points. Let's go to negative 3, 8, negative 2, 5, 0, 5, or sorry, negative 1, 4, 0, 5, and then 1, 8. And that's our graph. It's hopefully easy peasy. I hope you find this easy peasy. All right, let's move on to the next one. So this one, a little less fun because you can see already we're not given a perfect formula. You're going to probably have to use a calculator for this one. So students at Mr. Mackey's art class went outside to draw a rainbow, which follows a parabolic path and has the equation of y equals negative 0.1 and then x minus 1 squared plus 6. I wonder if that's the real formula for rainbows. Do you know rainbows are actually mostly circular, but because the way they're projected, the ground cuts them off, so you won't really see circular rainbows, but they are technically, if the color was to carry on, a big circle. Fun fact with Fozzie and Mr. Fowler. All right, so let's plug in some points. Oh, sorry. We can tell right off the bat, again, it's -1, so our vertex is going to be +1, and then you're left with 6, +6. So vertex is 1, 6. That's why we like vertex form. You can easily tell where the vertex is. All right, so let's plug in some numbers around that. -4. So -4 minus 1, -5, 5 squared, 25, times -0.1 plus 6, you get about 3.5. -2, plug that in. Again, feel free to use a calculator for this one. And then you'll get about 5.1, or hopefully you should. Plug in 0. Plug in 0. You get about 5.9. Plug in 1. We already know that one. That one's going to be 6. Plug in 2. You're going to get about 5.9. Now you're noticing a pattern. After 2, if we go to 4, 5.1, 6, you get 3.5. So now we have a bunch of points. We can graph them. So I went a little out of order, it looks like. But I start with my vertex, and then I went to my -4, and then 3.5, -2, 5.1, 0, 5.9, 2, 5.9, 4, 5.1, and 6, 3.5. So very flat curve for this rainbow, but you can hopefully see that outline right here. Hopefully you followed this rainbow. I should have put rainbow colors, but oh well. All right, so now a lot easier. They gave us the graphs. Thank goodness. All right, let's look at this. We can probably find it based on our vertex a little bit, because we know that our vertex, if we plug in 2 here, we get 2 minus 2, 0. So we know it's +2, and then we're left with -2. So +2, -2. So we know our vertex is going to be here. All right, and then I briefly mentioned this in a video previously, and hopefully your algebra teachers have mentioned this. Hopefully I mentioned this in the week before I was gone. Again, this is being filmed during spring break, not while I'm at my wedding trip. But the 3 in the front is positive, so we know that the ends of our quadratic formula are pointing up. So we know it's either going to be this red one pointing up, or our blue one, which is also the endpoints are going up. All right, so let's dive deeper. So if we plug in some points, again, we already know our vertex, 2, -2. If we plug in 0, 0 minus 2 is -2 squared, 4 times 3 is 12, 12 minus 2 is 10. plug in 1. 1 minus 2 is negative 1. 1 squared is 1. 1 times 3 is 3. 3 minus 2, 1 again. All right, now the pattern should repeat itself for 3. 3 minus 2 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 2 is 1. And then 4. 4 minus 2 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. So let's look at this. Okay, it's graph B. It's graph B because if we follow right here, you have your vertex at 2, negative 2, and then you have 1, 1, and 0, 10, 3, 1, 4, 10. So it's graph B. All right, Torito and O'Connor graphed two different quadratic functions in vertex form. Torito graphed f of x equals x plus 3 squared plus 1, and O'Connor graphed g of x equals negative 1 times x minus 3 squared plus 1. Both of them drew this graph, which is kind of crazy. Let's go over why. I guess I'll give it away that neither are correct. So let's go over why. Let's plug in some points for both of theirs. So our vertex for the first one would be negative 3 and then 1. So negative 3. 1, 2, 3, 1. So it'd be right here. So our first one's wrong because of that. And then if the next one would be, sorry, I jumped ahead. Let's look at the first one. So if we plugged in negative 5, f of x here, negative 5 plus 3, 2 squared plus 1, 5. We plug in negative 4 plus 3 is negative 1 squared, 1 plus 1 is 2. We know our vertex, which is negative 3, so we jump to negative 2, we get 2, negative 1, we get 5. So negative 1 here, so it would look a little different. It would most of the graph would be over here, like I mentioned before. So like negative 4 would be negative 2, negative 2 would be 2, negative 1 would be 5, and negative 5 would be 5. So it'd be over here, which is not where we want it. All right, so let's look at the next one. The next one, the vertex is 3, 1. So that's right so far. But let's plug in some points. So at 1, so 1 minus 3 squared, so 2 squared, we get negative 3. And that's because, remember, you have this negative on the outside. So this negative on the outside kind of flips everything. So if you look at this, if this is mostly correct, but because of the negative, it would be going down at these points. So create a negative graph. So that is why neither of them are correct. Hopefully you understood this section. In the next section, we're going to be talking about how to put stuff into vertex form, which can be slightly complicated, but hopefully you'll follow me and it'll make a lot of sense, because I think if you can put something into vertex form, it hopefully can be a lot easier when it comes to solving it. But I hope you enjoyed this section. See you in the next one.